Hey everyone, we are finally here with this series. So in today's video, I'll be starting off with June 1980 exam paper. This is A level and it was done here in Cameroon. So let's begin with question 1. Given that the roots of the equation ax squared plus bx plus c is equal to 0 are beta and n beta, show that n plus 1 squared ac is equal to nb squared. Okay, so first thing we have to know is that the sum of roots for a quadratic equation is negative b over a, and the product of roots is c over a. Now, where a, b, and c are just practically the coefficients right over here, so it just matches on, so we can just move on. Okay, so the roots, which are n beta and beta, would also have their own sum of new roots, let's just call it that way, which will be beta plus n beta, and if I resolve this, I'll have beta into 1 plus n. And then we have the product, let's do product of new roots, would be beta times n beta, which will be equal to n beta squared. So now we're just going to equate equivalent terms. So we have the sum of new roots, which goes with this. We have negative b over a should be equal to beta bracket 1 plus n, and as well the product of roots should be c over a equal to n beta squared. So since we're trying to show that this is this, you can notice that there is no beta in that formula, so it means we need to eliminate it. So I'm just going to go ahead and make beta right here the subject of the formula. Let's just call it equation 2, equation 1, right? So if I make beta the subject of the formula, this would be beta is equal to c over a n. First of all, divide by n, take the square root, and there we go. And then now I'm just going to substitute beta in equation number 1. Okay, this will be negative b over a equal to the square root of c over an times 1 plus n. And next thing we can do is square both sides, because we want to get rid of that square root. Just like that. If we square a negative number, we have positive, so this will go ahead to be b squared over a squared equals c over an bracket 1 plus n all squared. Okay, so we're just gonna have to move some things around here just to make it linear, like this one. Okay, so I'm going to multiply both sides by an and then divide by the c, so a squared c equal to 1 plus n squared. You can already see the equation coming up. So when we simplify this, we'll just see that one of the a's cancels out with a square at the bottom. This is just the law of indices. If you're not sure about this, let me know. Cancels out one of them. And then we would have n not squared, sorry, nb squared over ac equals 1 plus n, all that squared. Okay, so here they want to have nb squared on one side, so that will give us our final solution, which is nb squared is equal to n plus 1 all squared times AC. Quantum errata demonstratum. It means as required. Okay, Let's move on to the next question. A water polo team consists of a goalkeeper and 6 players to be selected from 11 players. Just 2 of the 11 players are goalkeepers. Find the number of ways in which the team may be selected. Okay, so we have 6 players to be selected from 11, but now they say 2 of them are goalkeepers. So we want to start by selecting the goalkeepers first. So out of the 11 players, there's 2 ways in which we can select a goalkeeper, but we need only 1 goalkeeper. So we're first of all going to minus the 2. Okay, so that we have 9. And now when we take out those 2 players, there's going to be 2 combination 1 because we need just 1 player. And now for the rest of them, which are 9, we need 6 players. So that will be out of 9, choose 6. So now for us to have a team, we need this and this. Keep in mind when you use n in mathematics, you have to multiply. So this would be 2 combination 1 times 9 combination 6. And if you use your calculators, you should get your answer. But then I'm just going to quickly do this. That's 2 factorial over 2 minus 1 factorial, 1 factorial times 9 factorial, factorial, 6 factorial. Okay, so 2 factorial over 1 times 9. We have to be consistent with the working. Okay, 9 factorial is the same as 9 times 7 times 8, skipped 1, times 6 factorial. Okay, 9876. This one is definitely going to cancel out. And then 3 factorial is the same as 3 times 2 factorial again. So I'm just going to simplify this. Goes here 3 times, 2 factorial goes here 4 times, and we're good. So then I should have 2, or 2 factorial is the same as 2. 2 times 3 times 7 times 4. I just grab my calculator here. 2 times 3 times 7 times 4, which is 168. So there's 168 ways you can select players for the team. Okay, there we go. Let's move on to question number 3. Find the numerical value for the term independent of x in the expansion 2x plus 1 over x squared. Okay, the first thing we notice is there is no degree given to us. That was the problem with this question back in the 1980s. I don't know. So we cannot really do this question, but I'll just drop this here. We would have to use the binomial expansion formula, which is n combination r a to the power n minus r b to the power r. Now what is a? A is going to be the first term, and then b is the second term. So if we had the degree, which is the n that we need, we'll be able to work this question out. And I really love binomials. So let's just move on. Question number 4. Find the set of values of x for which 2x squared plus 3x plus 2 is less than 4. Okay, that's a quadratic equation. That's why it even says set of values. So we're just going to work this out as normal. We'll start by, let me write this down first. Start by subtracting 4 on both sides to isolate this. So we have 2x squared plus 3x plus 2 minus 4 is negative 2 less than 0. Okay, now you can either use a quadratic formula here or you use the factor method. So I'm just going to use the factor method. I am going to have to multiply the 2 by this 2 since the coefficient of x squared is not 1. after I multiply these two together, I will get a 4. So practically, I'm doing 2x squared plus 3x minus 4. Or let me just put this at the top so we don't forget. Okay. That's better. So I'm finding two numbers that when I multiply, it gives me 4. But when I add, it gives me 3, which is pretty simple. I would take -1 and +4. So the two numbers we're searching for are -1, +4. Keep in mind this sign also applies to the 4, so let me just mention that over there. So this is supposed to be -4 right here, and then -1 plus 4, definitely a 3. So we just erase that. Okay, and we move on. So I'm going to use my factors. 2x squared, the numbers we had were +4, so 4x, and -1, so -1x minus 2 less than 0. Then I'm just going to factorize 2x here. X plus 2 would be left over. I can factorize -1 here so that x plus 2 is still left over. Keep in mind we have to make sure these internal ones are the same. Okay, and then 2x, hold on, we factor out the x plus 2 and then we do 2x minus 1 less than 0, just like that, and then we take each of them being equal to 0, because if two numbers multiply to give you a 0, then either of them has to be a 0, right? Okay, next we have x would be less than -2, or we have x less than +1, divide both sides by 2. So in this case, we can rewrite the equation. We always have to start with a smaller one. So -2 has to go first. This would be -2 less than, if x is less than -2, that means -2 is greater than x. And then we have x less than a half. Okay, perfect. So we have x in the middle. We combine it to get our interval. So -2 less than, why do I keep saying less than? Greater than x, but less than a half. And now for the set of values, well, this already represents the set of values. You can write them out if you want to, but then there's going to be a lot of them. So question number 5. Prove that sine theta plus sine 2 theta over 1 plus cos theta plus cos 2 theta is equal to tan theta when cos theta is not equal to half and also not equal to 0. First things first, we know tan theta is the same as sine theta over cos theta. So we want to make sure that this left hand side would equate to this right hand side. So I'm just going to focus on the left hand side of the equation. There we have some trigonometric identities. So let's start with the first one. Sine 2 theta, which is the same as 2 sine theta cos theta. You can check your formula booklet for these trigonometric identities. Then we also have cos 2 theta in the bottom, which would be cos square theta minus sine square theta. I'm just going to substitute these, nice and easy. So this would imply sine theta is equal to, oh pardon me, plus 2 sine theta cos theta divided by 1 plus cos theta plus cos square of theta minus sine square of theta. Okay, in the numerator I can factor out sine theta, so this would be equal to sine theta brackets 1 plus 2 cos theta. The denominator, I'm just going to expand this bracket, but that wouldn't really do much for us. So here's the thing, we can substitute some identities here. We want to get cos theta as our result in the bottom, so we have to replace this sine theta so it goes away. Okay, that's what we focus on. So we have to find an identity that will replace sine with cos, and the only one I can think of right now is cos squared theta plus sine squared theta equal to 1. Just like this, and there we go. So now I'll replace it over here when I'm writing this denominator. So 1 plus cos theta plus cos squared of theta minus parentheses 1 minus cos squared theta. There we go. Just section this out for a bit. Okay, so now sine theta parentheses 1 plus 2 cos theta all over 1 plus cos theta plus cos squared of theta minus 1 plus cos squared of theta. I'm just expanding the bracket. Now the cos squared thetas would add up to give 2 cos squared theta, but then the ones would cancel out. The denominator for now, this would be cos theta plus 2 cos theta, cos squared theta. Okay, factorize this. I'm gonna have cos theta parentheses 1 plus 2 cos theta. Sorry, you must have noticed I'm using parentheses interchangeably with brackets. They all mean the same thing. Okay, there we go. We have the factored form. Now we can substitute back into the original equation. So that would be sine theta into 1 plus 2 cos theta over cos theta into 1 plus 2 cos theta. And this just cancels out nice and easy. And we have sine theta over cos theta, which is tan of theta. Quantum errata demonstratum, just as required. Okay, moving on to the next question, number 6. Given that x is equal to -1 plus 3i, express z plus 2 over z in the form a plus bi, where a and b are real. Alright then, so we need 2 over z, but I'm just going to substitute the values of z into the equation directly because that's quite easy. Oh, this is a typo. This is supposed to be z, pardon me. Okay, so when I was typing that I made a mistake. So this would be -1 plus 3i plus 2 over -1 plus 3i yet again. And then we can put this over 1 so that we can find the common denominator. Okay, so that is just basically the same as doing the butterfly method, which is just crossing over like so, crisscross, so that 1 plus 3i multiplies -1 plus 3i plus 2 which will multiply 1. over negative 1 plus 3i. Expand the brackets. That will be 1 minus 3i plus 9i squared. But keep in mind I squared is the same as negative 1, so we replace that. Plus 2. There we go. And now we have 1 plus 2, which is bring the like terms together. 1 plus 2, minus 9, so that's another like term, which would be 3 minus 9. That gives us a negative 6. And we have other like terms, which would be negative 3 minus 3, and that gives us negative 6i yet again over negative 1 plus 3i. Now we have to rationalize the denominator to be able to get rid of that format. So we have to multiply the top and the bottom by the conjugate of this complex number. There we go. This would be this would be equal to negative 6 times negative 1 is positive 6 plus 18i plus 6i plus 18i squared. Yet again, replace that by minus 1 over 1 plus 3i minus 3i minus 9i squared, which is negative 1. Okay, this would be 6 minus 18, if I'm considering the like terms. 6 minus 18, which is negative 12. 18 plus 6, I gives us a 24i over, or here, these ones cancel out. 1 minus minus 9 is going to be 10. And then finally, we can now divide each of the terms by 10, so that we have the real part and the imaginary part. So this will be negative 10 over negative 12 over 10 plus 24i over 10. Negative 1.2, or plus 2.4i. You can do it that way, or for those who like fractions, we would simplify by dividing by 2, negative 6 over 5 plus 12 over 5i. You choose. But I know a lot of students hate fractions, so let's move on. Question number 7. Find the equation of the tangent to the curve ay squared equals to x cubed at the point at squared at cubed, where a is greater than 0 and t is a parameter. Okay, so if we want to find the equation to the tangent to any curve or any line, we have to keep in mind that the gradient is the same as the rate of change with x. So we just need to find the gradient of this curve. Now what we have to do is implicit differentiation. So we're going to implicitly differentiate this with respect to x. Okay, let's start off with the left hand side. So I'm just going to write this down. Ay squared equal to x cubed. To implicitly differentiate this, we can see that this is the product of two different terms, so we use the product rule. So this would be a we keep that constant, then we differentiate y, so it's going to be 2y dy by dx plus the derivative of a is 0, then we keep y squared constant equals the derivative of x cubed is just 3x squared. Okay, so this would be 2ay dy by dx equal to 3x squared, hence dy by dx is equal to 3x squared over 2ay. Okay, they've given us the point, so we say at the point 80 squared 80 cubed, what happens next? We substitute to get dy by dx. This would be 3at squared, all that squared, over 2a times 80 cubed. At the numerator, we're going to get 3a squared t to the power 4 over 2a squared t cubed. Then we simplify using the law of indices, and we see that a squared here cancels out, and then 4 minus 3 is 1, so we take out 3 t's from 4, and then we get 3, 1 second, we get 3t over 2. Now that's the derivative. To find the equation of a tangent, you have to keep in mind that dy by dx is also equal to y minus y1 over x minus x1, right? Or you simply use the formula y minus y1 is equal to the gradient times x minus x1. Y minus at cubed should be equal to 3t over 2 parentheses x minus x1 is at all squared. Okay, multiply all through by 2, and then we're going to get 2y minus 2at cubed equal to 3tx, I'm just expanding the bracket at the same time, minus 3t cubed a. So I'm going to bring the x and the y to one side of the equation. This would be 2y minus 3x tx equals negative 3 at cubed plus 2 at cubed. Okay, then 2y minus 3tx equals negative at cubed, and that is the equation to the tangent, the equation of the tangent to the curve. Moving on to question number 8. Given that x is equal to 2 plus 2e to the power negative 2t minus e to the power negative 3t, find the maximum value of x as t varies. For us to find the maximum value as t varies, it means we have to find, first of all, the derivative of x with respect to t, then we substitute it and get the y value as well. Dx by dt is equal to the derivative of a number which is 2 is 0, so 0 plus the derivative of 2e to the power negative 2t with respect to t minus the derivative of e to the power negative 3t over dt. Okay, I just want to break this down easily for you guys. So let's take this second part and differentiate it using the product rule. Okay, so this derivative dE negative 2t dt, we can keep two constant first, and then we differentiate e to the power negative 2t. The derivative of e to the power negative of 2t would be negative 2 multiplied by e to the power negative 2t. That's basically it. Then you would get negative 4 e to the power negative 2t. The derivative of this one right here is easy as well. So the derivative of e to the power negative 3t would be differentiating the power, which is negative 3, then multiplying it by e to the power negative 3t, so that we get the same thing basically. There's nothing to simplify here. Let's substitute into our main equation. Dx by dt would be 0 minus 4 e to the power negative 2t plus the negative, we put the derivative here, negative 3e to the power negative 3t. This would be negative 4 e to the power minus 2t plus 3e to the power negative 3t. That's the derivative. Now, a maximum value occurs when the derivative or the rate of change, which is this, is equal to 0. So I'm just going to equate this to 0 right over here, so that we can work out the value of t, the time at which this occurs. So now I'm just going to go ahead and add 4e to the power negative 2t on both sides, so that we have 4e to the power minus 2t equals 3e to the power 3t, pardon me, this is even supposed to be negative. Okay, simplify. So I would divide both sides by e to the power minus 3t because that's the smaller number. So I'm going to get rid of e to the power minus 3t, just like this. And then we're going to create more space real quick. There we go. We use the law of indices. This will be 4e to the power negative 2t minus e to the power negative 3t. And then over here we have 3e to the power, oh, it cancels out, so we have just a 3. And then we're going to have 4, negative 2 plus 3 is 1. So 4e to the power t equal to 3. So therefore e to the power t is 3/4. Therefore t, if I take the natural log on both sides, so the natural log of e to the power t should be equal to the natural log of 3/4. So t is ln of 3/4. The actual value using the calculator would be t is equal to 0.287. Okay, now that we know where this maximum occurs or what time it occurs, we can substitute to get the x value. So x would be 2 plus 2e to the power minus 2 times 0.287. This is a negative number. When you do a natural log of a number, you should get negative, so this is supposed to be minus, pardon me, plus negative 3 e to the power negative 0.287 times 3. Okay, so you can actually work that out with the calculator. So x would be equal to 3.185, and therefore the maximum value at which this occurs would be negative 0.287, 3.185. There we go. Let's move on. Question number 9. Find the points of intersection of the circle x squared plus y squared minus 6x plus 2y minus 17 equal to 0 and the line x minus y plus 2 equal to 0. Show that an equation of the circle which has these points as ends of the diameter is, that equation. Now show also that the circle and the circle x squared plus y squared minus 8x minus 2y minus 13 equal to 0 touch externally. We are going to find the point of intersection, which is simply working out this question as a pair of simultaneous equations. So we have here x squared plus y squared minus 6x plus 2y minus 17 equal to 0. And then we have x minus y plus 2 equal to 0. This can be named as equation 1 and 2. I'm going to use the substitution method, so I'm going to make x the subject, or even y the subject over here, and substitute it into equation number 1. So to make y the subject, we add y to both sides, and then we would have positive y being equal to x plus 2, right? So then in equation 1, we should get x squared plus x plus 2 squared minus 6x plus 2 times x plus 2 minus 17 equal to 0. Let me just map this out now before it's too late. Okay, then this will give us x squared plus x squared plus 2 times x is 2x, so we have 2 x's, which makes 4x plus 4 minus 6x plus 2x plus 4 minus 17 equal to a 0. Then we bring the like terms together. So I'm just going to color code this x squares. That will be x squared. Then we have x's, 4 minus 6 plus 2, which is a 0, cancels out, so 0x. And then lastly, the constants, which are 4 and 4 again. 4 plus 4, which is 8, minus 17, that will be a negative 9. So x squared minus 9 equal to 0. Oh, this first one, x squared plus x squared, has to be 2x squared. And then now we can work out x, which would be equal to 9 over 2. So x would be the square root of positive and negative 9 over 2. Simplify that again. X would be positive negative 3 over root 2. Rationalize the denominator. Positive or negative 3 root 2 over 2. When x, I would like to change the color. When x is equal to positive 3 root 2, what is the value of y? Y is just the value of x. Oh, that should be over 2. So 3 root 2 over 2 plus 2. Get a common denominator. Y would be equal to 3 root 2 plus 4 over 2, and then when x equal to negative of 3 root 2 over 2, I'm saying something else and writing something else, negative 3 root 2 over 2, we would have y being equal to negative 3 root 2 over 2 plus 2 again. Okay, minus plus 4 over 2. So these are the points of intersection. Let's move on to part number 2. Show that an equation of the circle which has these points as ends of a diameter is equal to this. So if you have a circle has these points as ends of the diameter, it means that one point, if we remember quite well, when x was positive, we had 3 root 2 over 2, comma, what was the value? We had positive as well, so we had 3 root 2 plus 4 over 2. On the opposite side, we're going to have, so I'm just going to bring this here, negative 3 root 2 over 2 should give me negative 3 root 2 plus 4 over 2. And there we have it. So for us to find the equation of a circle which has endpoints as diameter, we first of all need to look for the center, which is called the midpoint at this point, basically center. And then what else do we need? We need the radius. The radius is equal to half the distance from point 1 to point 2. Okay, let's just call that d1, 2, just like this. Okay, so the center is the midpoint, so we're basically going to add corresponding coordinates, divide them by 2. All right, it looks very cumbersome because they are huge fractions. So 3 root 2 over 2 plus negative 3 root 2 over 2. All of this you add it up, divided by 2, and then for the y we should get 3 root 2 plus 4 plus okay, let's erase this, plus negative 3 root 2 plus 4 over 2 over 2. You add them both, you divide that by 2 to get the midpoint. Center would be equal to, this one is going to give me a 0, and then this one, since they have the same denominators, we can see that this 3 root 2 is going to cancel out, yes, and then we would have 4 plus 4, which is 8. So this is 8 over 2. Then we divide by 2, so we divide this by 2. So 8 divided by 2 is 4. 4 divided by another 2 is 2. That is the center. And then I'm just going to go ahead and erase this. Okay, next thing we want to find is the radius, which is half the value of the distance between point 1 and point number 2, right? Okay, or it's just the distance between point 1 and the center, or point 2 and the center. See that? So point 1 and the center, or point 2 and the center. So I'm just going to work it out directly rather than working the whole thing out and dividing by 2. Okay, so let's find the distance between point 1 and the center, which was 0, 2. Don't forget, you can also use your formula booklet. You subtract both of the corresponding coordinates, square them, take the square root, y1 squared. Keep in mind the order does not really matter, because when you square it, it should give you a positive number always. All right then, so we are finding the distance between 3 root 2 over 2 and 0, comma 3 root 2 plus 4 over 2 and 2. I just had to put this like so, so that I can align it. You know, when I align them, it's easier to see what I'm subtracting. X and X, Y and Y. So D1C is equal to X2, so 0 minus 3 root 2 over 2 squared plus 4 over 2, all of this squared. Okay, so the distance would be, this one is just going to be positive, so I'm just going to square 3, which is 9, square root 2, which is 2, square 2, which is 4, plus, well, here common denominator 4 minus, please put these in brackets because you can easily make a mistake and forget that you are subtracting all 8 terms, so they're all going to become negative. So 3 root 2 minus 4, like so, over the 2. Okay, so now you see that the 4 cancels out, yeah, and then when you square it, what happens? It gives you exactly the same value as the first one we had. Okay, so this would be D1C equal to square root of 9, well, simplifying this is going to be 9 over 2 plus, I said will still be 9 over 2. That gives 18 over 2, which is still 9, or square root. So the the distance is a 3. And finally, we can say that the radius of the circle would be a 3. Now, how do you get the equation of the radius of a circle? We have the general formula, x minus h squared plus y minus k squared equal to r squared. H and k, let me just make this clear, h and k would be the center, which was 0, 2. Substituting this, x minus 0 squared plus y minus 2 squared equals 3 squared. So x squared plus, well, for a method again, y squared minus 4, y plus 4 should be 9. Bringing this one to the right hand side, or the left hand side, pardon me, will be x squared plus y squared plus 4 minus 9 minus 4, y equal to 0. And then finally, x squared plus y squared minus 4y minus 5 is equal to 0, which is the equation that they had in the beginning. Let's check to see if it is as required, because when I was working this out, I noticed that some of the questions had typos. So you see here they have a positive, and I worked this out a couple of times and I got negative. Okay, so this is just the difference right here. That's the equation of the circle. Last section, show also that the circle and this particular circle, they touch externally. So the condition for two circles to touch externally, let's say we have this. Let's take a look. There we go. They're touching externally. What do you notice? The radius or the radii, r plus r, should be the same as the distance between their actual centers. So we have to find the center of this circle. We're going to work out the center using completing the square method. All right, so this would be x squared plus y squared minus 8x minus 2y minus 13 equals 0. To complete each of the squares, let's first of all bring the x's. So x squared minus 8x plus y squared minus 2y, and then we isolate the constant. Okay, completing the square, you find half of 8, square it, add on both sides. So half of 8 is 4, like so. Add on both sides, half of 8, negative 8. Keep in mind the sign matters. Square, and then plus y minus 2y would be plus negative 1 square equals 13 plus negative 4 squared plus negative 1 squared. Completing the square, we bring these together like so, and then we should get x minus 4 squared plus y minus 1 squared equals 30. We can now compare this to the actual equation of a circle, which I have over here, to see that the center would be equal to 4, 1, and the radius should just be the square root of 30. Okay, so show that the circle and this one, so the circle, which is which one, is it has to be the original one, either this or even this one. So we are going to start logically with the one given in the question, okay, because that's how it goes. You go with the original. So we're gonna try to find the center of the original one. The original circle was x squared, so original is x squared minus 6, x squared minus 6x plus y squared plus 2y minus 17 equal to 0. Again, using completing the square method, this would be x, well, I don't have to explain a lot again, so x minus 3 squared plus y plus 1 squared should be equal to 17 plus 3 squared plus 1 squared, which gives me a 27. So 27, just like this. Okay, center 3, negative 1, radius is root of 27. Okay, then we would have to show that the sum of the radii is equal to distance between the circles, the centers, pardon me. Okay, here this is center 1, center 2. Find the distance between C1, C2. That I should get 4 minus 3 squared plus 1 minus 1 squared, square rooted. That would be 1 squared, which is 1, plus 2 squared which is just 4. So 1 plus 2 squared is 4, which is the root of 5. And then now the sum of their radii, radii 1, radii 2, should be root 30 plus root 27, which is 5.4 plus 5.196, which is 10.6. And what do we notice here? That this diameter is not equal to a center. I know you're wondering why. Well, I had done this question, like I said, a couple of times, and I noticed that there was a typo in this question, but at least I decided to show you guys the working, because you would have to understand how circles touch externally. You still gain some knowledge, even though they are not equal. That's about it. Moving on to question number 10. The sum of the first n terms of an arithmetic progression is n squared plus 2n. Find the n term of the series. Find also the number of terms whose sum is 575. Okay, for each of the series, find the set of values of r for which the series is convergent and find the corresponding sum to infinity of the series. Okay, let's start with the first part, which is finding the n term. Okay, so the sum of the first n terms is given as n squared plus 2n, and they want us to find the actual n term. Now, the n term of any arithmetic progression, the n term of any arithmetic progression is a plus n minus 1 d, which is a common difference. So we need to find a, the first term, the second term, and we find the common difference. Okay, so now let's go ahead and find about the sum of the first 1 to 3 terms, right? So the sum of the first term, well, it's just going to be the single term, so that is the same as the actual first term, right? Okay, this is going to be when n is 1, so that will be 1 squared plus 2 times 1, which is 2 plus 1, which is 3. Okay, and then we have the sum of the first 2 terms, which is basically 2 squared plus 2 times 2, which is 8. But keep in mind that if you want to get the second term, since we already know the first term, want to get the second term, like so, what do? We take the sum of the first 2 and we minus the first one. So we take the sum of the first 2 minus the first one. That gives you u2. Lastly, sum of the first 3 terms would be 2 squared plus, 3 squared plus 2 times 3 equal to 9 plus 6, which is a 15. And yet again, the third term would be the sum of all the 3 minus the sum of all the 2. 15 minus 5. Sorry, the sum of all the 2. Okay, minus 8 rather. Okay, that's 8. And this would be 15 minus 8. Okay, I'm having a brain freeze, which is 7. Okay, our sequence would be 3, 5, 7, and we can definitely see a pattern. So the common difference is 2. And finally, n term is going to be 3 plus n minus 1, common difference of 2, 3, common difference of 2, 3 plus 2n minus 2, so 1 plus 2n. That's our nth term. And then find also the number of terms whose sum is 575. The number of terms whose sum is 575. Whose sum, so the sum of the number of terms whose sum is 575. In that case, we have to do n squared. We just equate n squared plus 2n equals 575. This one is actually pretty simple. Okay, sum of n terms, which is 575, and we saw that it's n squared plus 2n equal to 575. Okay, so this is the quadratic, and we can use the quadratic formula, all right, since the number is really huge. Okay, quadratic formula would be n. I'm not going to write that down. We have negative b, which is 2. So this is a, this is b, this is c, just in case. So negative 2 plus or minus square root b squared, so 2 squared, which is 4, minus 4a, which is just 1, c, 575, over 2a. So n equals plus or minus negative 2 over square root of b2304 over 2. Square root of that would be 48 over 2. And then we can work out the values of n. Negative 2 plus, why did I still put the square root? I don't know why, but it should be 48 over 2. And then this first one would be 23. In n, well, we don't even need to work out the second one because you cannot have negative terms. All right, there's no way we can have negative terms, so this one does not work. So the sum of the first 23 terms should give us that value. For a series to be convergent, the magnitude of r has to be less than 1. What does that mean? Negative 1 should be less than r, should be less than 1. Okay, so they want us to find r for each of them. We have to find the common ratios. So for series number a, if you want to find the common ratio, you just take the second term over the first term, third term over the second term. So 1 plus r over 1 should be equal to 1 plus r, all of this squared, over 1 plus r. So then common ratio should be equal to, okay, this looks weird because there's 2r, so I'm just going to put this as c. Common ratio should be just 1 plus r, right? And now for the first series, for it to be convergent, the magnitude of this, so magnitude of CR, has to be less than 1. So I'm just going to substitute it using this notion. Right over here, I'm going to have negative 1 should be less than 1 plus r less than 1, right? Then we work out the value of r by subtracting 1 on all the sides of the equation, so that this would be negative 2 should be less than r less than a 0. That's the first one, right? And then for the second series, wait a second, okay, this would be 1 over 1 plus r divided by 1 should be equal, I want to just centralize this, it's always good to have a center, should be equal to 1 over 1 plus r squared over 1 over 1 plus r. Well, it's pretty obvious. that the common ratio would be 1 over 1 plus r. All right, so the magnitude of this again, magnitude should be less than 1. So this would imply 1 over 1 plus r less than 1 less than minus 1. Okay, so I'm just going to break this up into two parts. All right, let's start off with this side. So we have 1 plus r times the negative 1, right, should be less than 1. And then we have negative 1 minus r less than 1. I would just take the r to the other side of the equation so that it becomes positive, and bring the 1 to this side, so it becomes negative 1 minus 1 less than r, okay, which is negative 2 is less than r. That's the first part. Part number 2. So I'm going to take the right hand side. 1 over 1 plus r should be less than 1, so that we do 1 is less than 1 plus r, and then I minus 1 here, minus 1 here, to get 0 less than r, which means r is greater than 0. Oh no, which means, yeah, r is greater than 0. So the first solution was negative 2 less than r. Second equation was r greater than 0. Combine them together, I should get my solution. Negative 2 less than r, since these are in the middle, less than 0. And that looks okay. Perfect. Moving on to question number 11. Express 3 cos x plus 4 sin x in the form r cos x minus a, where r is a constant and a is acute. Hence or otherwise, find the greatest and least values of 3 cos x plus 4 sin x all squared, and find the nearest tenth of a degree. All the solutions of the equation 3 cos x plus 4 sin x equal to 5 root 3 over 2 in the interval 0 degrees to 360 degrees. You would know that r cos of x minus alpha should be equal to a cos x plus b sin x. Now, what is r? R here is the squared of these terms, or square root, all right? And then alpha is going to be the tan inverse of b over a. Looking at our question, we can see that a is this and b is this. So I'm just going to rewrite that equation just so that we can have it closer to us. 4 sin x. Okay, this is a, this is b. So r would be 3 squared plus 4 squared, which is Pythagoras. A lot of you have encountered this before, so it's easy. 5, and then alpha, tan inverse of 4/3, which would be equal to 53.1 degrees. And the final answer are, sorry, we're writing it in the form r cos minus alpha. Okay, I didn't see that properly. So x minus alpha, or the a, kind of looks like an a though. So this would be 5 cos x minus 53.13, which is acute. There we go. Smiley face. Hence or otherwise, find the greatest and the least values of this all squared. Now the greatest value, so I'm just going to take the hence. Okay, hence means you should use your previous answer to work out the next. So use our answer knowing that this is also the same as 5 cos x minus 53.13 degree, right? We want to work out the greatest and the least values of this value all squared. Let's look at the graph of cos. When we have cos 0 is 1, cos 90. We would see that it attains its maximum or its peak when that the cos of the angle must be 1. So how does this help us? It means all of this angle here, theta, when you find the cos of all of this, it should give you 1. And what do we see? That the angle at which it is 1, the angle at which is 1 is definitely 0 because cos of 0 is 1. So what does that mean? All of this in here, which is the angle theta, has to be 0. So 5 cos of 0 degrees all squared would give us the maximum value that we are looking for. So the maximum value of this would be 5 cos 0, 5 squared, which is 25. Okay, so we have to find the least value. The least value occurs when we have a trough, and that is when it's minus 1. Cos of the angle is, so cos of the angle is minus 1. So then this occurs at theta being 180 degrees. That we can find the value of for which all of this 5 cos of 180, because this has to be equal to 180 squared, which is 5 cos of 180 is -1. So -1 all squared, it will still be 25. So if I analyze this, maybe the question just wanted to put a term without the square so that will make sense. Here we would have a -5. Here we would have a +5 if there were no square terms, and that will make more sense. Least value being -5, greatest value being +5. You get what I'm saying? But we just use the question as it is. So if we were to be this way, that would be the maximum and positive value. So the next part of the question says find your nearest degree, all the solutions of this in the interval. Okay, so the solutions of 3 cos x plus 4 sin x equals 5√3/2. Okay, so I'm just going to replace this with its equivalent right here. This is the same as r cos x minus alpha, which is 5 cos x minus 53.13 equals 5√3/2. They just want us to find to the nearest 10 degrees all the solutions. Okay, all the values of x. Well, divide both sides by 5 to first of all eliminate it. Okay, and then we are now going to take the cos inverse. So x minus 53.13 equal to the cos inverse of √3/2. So x minus 53.13 should be equal to 30 degrees. Now, they've given us in the interval 0 is less than x, it's less than 360 degrees. So we know that x is equal to 30 plus this, which is 83.13. Using the 4 quadrants, where we have cast. Cos is positive here and here. So the first angle would be 83.13. And then the second angle would be right over here. In this case, we have to do 360 degrees minus 83.13 to get 276.87, which is 277 degrees. Those are all the values of x. Next question. Represent on the same Argand diagram the loci given by the equations z minus 3 absolute value equal to 3, absolute value of z equals absolute value of z minus 2. Then obtain the complex numbers corresponding to the point of intersection of these loci. So basically locus is just the path taken or the path drawn by each of these complex numbers. The path can be a circle, it can be a curve or whatnot. So if we want to find the locus of each of these, let's start by writing it down first. Z minus 3 equal to 3. So we can find the equations of each of the complex numbers. So we let z be equal to x plus yi. Okay, substitute it in there. X plus yi minus 3. As you can see, it has only a real part, right? So in this case, we have x minus 3 all squared to get the absolute value plus y, well, it's just going to be alone I, okay? Squared I equal to 3. You square the side as well. This is going to be x minus 3 squared plus y squared equal to 9. And so center is 3, 0, like I said before. Radius is 3. So if we visualize this just for a bit, right? It's a circle with center 0, 3. So 3, 0, pardon me. Okay, 3 on the x-axis. And then we have a circle. I'm just going to have to start from the center. Then I just move this down. Okay. Then I can push this to make a bit of sense. Okay, 0, 3. That's the center. Now the radius, which is the distance from this complex number, is 3. So the diagram would have to look like this. There we go, from its center. Okay, that's the first Argand diagram. The second would be z minus, so magnitude of z equal to z minus 2. Okay, so again, we let z be x plus yi. Replace these. Magnitude 6 plus yi minus 2. Magnitude. Over here, we're just going to have x squared plus y squared. And then over here, x minus 2, which is the real part. Well, this one is the only one. We add this up, y squared. Okay, expanding these brackets, x squared minus 4x plus 4 plus y. And then here we have x squared plus y squared. And it's obvious that this x squares would cancel. This is a y squared, so it will also have to cancel out. And then we have add 4x on both sides, okay? Just to make sure that this will be 4x equal to 4, x equal to 1. So the locus of this is actually a straight line, okay? Like I said, it can be a curve, it can be anything, it can be a circle. So I'm just going to draw x equal to 1. So if this is 3, 1 must be right over here. It passes through that point. So let's just do it like this. That's the second locus. Next part says obtain the complex numbers corresponding to the point of intersection of these loci. Intersection of this loci. This is where they intersect, right over here and right over here, right? So we have to get those points. Keep in mind the distance between both of them is 2. So this is 2. Therefore, the hypotenuse should be 3 as well. Why? Because it's the distance from the center to any point of the circle, which is perfect. So if I just extrapolate this would be 3, 2. We have this value which we don't know. Pythagoras is our best friend, so we know that 3 squared equal to y squared plus 2 squared. Y equal to square root of 9 minus 4, which is 5. Square root of 5. Okay, so the y coordinate here would be positive root 5. So it means that the point of intersection is when x is 1, we have two values, positive and negative root 5. So that gives us 1 comma root 5, 1 comma negative root 5. There we go. Next question, find the complex number z whose argument is pi over 4, which satisfies this equation. Z plus 2 should be equal to z minus 4. Okay, and they want us to find the complex number z whose argument. So the argument for z is pi over 4. Keep in mind, argument is practically the same as the tangent. The y over x is the same as the argument of z. Okay, we need to find x and y. Okay, so as always, our z is x plus y, I plus 2 plus I minus 4 plus I, absolute value. So we're going to have x plus 2 squared on this side plus y plus 1 I squared on the other side equal to x minus 4 squared plus y plus 1 squared. Expanding the brackets, x squared plus 4x plus 4 plus y squared plus 2y plus 1 equals x squared minus 8x plus 16 plus y squared plus 2y plus 1. Okay, bringing the like terms together. So x squared cancels x squared, y squared cancels y squared, and we have the x's. So I'm going to add 8x on both sides, and then I'm going to subtract 2y. Oh, it cancels out on both sides. Okay, the 1 as well cancels this 1. 4x plus 8x, which is 12x, plus 4 plus this one gives us 0. So that's it. And then here we have a 16. Okay, I did not see that. Plus this one cancels out 0. Okay, so then 12x is equal to 16 minus 4, which is also 12. So x is equal to a 1. Okay, at least we know x is equal to 1. Now we need to find y. But so remember, I said arc of z, which is the same as tan of the angle, right? It means when you work out the tan inverse of y over x, you should get pi over 4, which is the same as arc z. So let me fix this up. This is supposed to be y over x. That's the correct one. Okay, so let's see. From here, if I take tan to the other side, it's going to be tan of pi over 4 equal to y over x, which is just 1. So then pi over 4, tan of pi over 4 is 1 as well. So y over 1, y is equal to 1. That's good. So definitely z, which is x plus yi, is 1 plus 1i, which is 1 plus I. Question 14. Given that y is equal to k plus x cos x, where k is a constant, find d squared y by dx squared plus y and show that it is independent of k. Differentiate with respect to x that function, and then given that x and y vary so that ax plus by is equal to c, where a, b, and c are constants, show that the minimum value of x squared plus y squared is c squared over a squared plus b squared. Okay, guys, I challenge you to do this question first before you even watch the video, especially the third section. Okay, let's get started. So we want to show that, or we want to first of all find d squared y by dx squared. Means we're going to be differentiating this twice. All right, then, so we know that y is equal to k plus x cos x, and we can see that is the product of two different functions, so it's always easier to use the product rule. I'm just going to let u be k plus x, v be cos x. Then I'm going to find each of the derivative. So du by dx, I'm just going to write that as du, would be x because the derivative of k is 0, and then dv, the derivative of cos, is negative sine x. Let's use the product rule. So dy by dx for this is going to be u dv, u dv plus v du, which is equal to, let's put that over here, which would be u, which is k plus x dv negative sine x, plus v is cos of x, the derivative of u, it is supposed to be a 1. Okay, pardon me, this is a 1 because when you differentiate x you should get a 1 and not an x again, so this is supposed to be 1. All right then, so we expand the brackets, negative k sine x plus negative x sine x plus cos x. Okay, let's differentiate this again one more time. This would be u v. Okay, I'm going to do it a bit faster so that we get d squared y over dx squared. For the first term, which is this one I'm focusing on, I'm going to put that in green. We have u, keep the u constant, differentiate sine x, which gives us cos x, plus v, which is sine x, differentiate the k, or the negative k, it gives us 0, plus our next term. So let's separate these with parentheses. Our next term which we're differentiating is this one. U is negative x, dv is cos x, plus v, which is sine x, du, which is negative 1. Okay, Then finally, the derivative of cosx is negative sine of x. I'm going to bring the terms with cos together. So this right here and this right here. That makes negative k cos of x minus x cos of x plus, well, this boils down to a 0, so it cancels out. And then we have negative sine x over here, negative sine x, and another negative sine of x. I can then factor out cos of x, so this would be equal to cos x, sorry, negative cos of x, because both of them actually have negative. This would be k plus x, or minus 2 sine x. Okay, that is d squared y by dx squared. Now what we want to do is add it on to y to show that it's independent of x. So in this case, we should have this value, negative cos k plus x minus 2 sine x, plus the y value. Y is actually the same as k plus x. This is supposed to be cos x over here. Okay, cos of x. I'm just saying so because even if you reverse it, it should give you the same value. So let me just reverse this, the order in which I'm writing it. K plus x, cos x, because I factored out the cos x, right? And then we see that this is going to cancel out nice and neatly. And we have our value as negative 2 sine of x. And we can see that d squared y of dx squared is equal to negative 2 sine x, which is actually independent of k. There's no k in here, so it doesn't depend on it. Okay, there we go, just as required. Quantum errata demonstratum. Okay, question number 2, Roman 2 to be precise. Differentiate with respect to x. We have 1 minus x over 1 plus x all squared. Okay, we want to find the derivative of 1 minus x over 1 plus x all squared. Let's verify. Yes, 1 minus x. Okay, with respect to x. Okay, so I can actually separate this to the top and into the bottom. Dx. Okay, just like that. And then I would use the chain rule to differentiate the top and the bottom separately, so that I can use it in the quotient rule. So we have a sequence of 2 rules here, quotient rule and chain rule. So I'm going to first of all let this equal to the u minus x squared, so that u prime, or the derivative of u, let's call it du, would be equal to, all right, using the quotient rule, you first of all differentiate the middle, which is going to be negative 1. You bring down the power, you write the full term, subtract 1. This would be negative 2 parentheses 1 minus x, right? Okay, and the same thing goes for v, 1 plus x all squared dv equals 2, differentiate the middle, 1 plus x, the power 2 minus 1, so dv would be 2, 1 plus x. Let's use them in the quotient rule formula. The quotient rule, dy by dx, actually states that bottom d top, okay, this was one of our favorites in high school, bottom, which is v, the bottom d top, derivative of the top, d top minus top u d bottom over bottom squared. Okay, then we would see that dy by dx is actually equal to v, which is 1 plus x all squared, du is -2 bracket 1 minus x minus, put a huge bracket because you don't want to get some signs mixed up. Okay, u dv 1 minus x squared, derivative of the bottom, so dv is 2 brackets 1 plus x, just like that, all over bottom squared 1 plus x squared, all this squared. Okay, let me use the black color. If we take a keen look here, right, we'll see that there are some parts of the question that we can factor out. So in the numerator, what do we got? We have 1 plus x all squared, and then over here we have a 1 plus x. Here we have 1 over 1 minus x, and then here we have 2 of them. So let's factor those out first. 1 plus x, I'm going to factor 1 of them out, and 1 minus x right over here, big bracket. -2 is going to be left inside, and then 1 of the 1 plus x will be left inside as well for the first term, minus the second term. We would have 1 of the 1 minus x being left over here, 2 as well, and that's practically it. Okay, all of this divided by 1 plus x to the power 4. Since we've taken out 1 plus x, we can actually cancel out 1 of the 1 plus x. So this would be cancelled out to have 3 left over. We can actually factor out this 2 as well. Okay, that's good. So that makes our work a lot easier. So the 2 can go on the outside, just like so. And then our resulting equation would be 2 brackets 1 minus x brackets 1 plus x. This is a negative on the outside, please don't forget, minus 1 minus x brackets 1 plus x cubed. Okay, I'm just going to work with this middle section right here real quickly and simplify it before I substitute it back. Okay, so in this case, the middle section, which is -1 plus x minus 1 minus x, will be -1 minus x minus 1 plus x, and then x's cancel out to give us -2 in the end. So all of these brackets boils down to a -2. Perfect. So this would be 2 brackets 1 minus x brackets -2 over 1 plus x cubed, and our final answer would be -4 into 1 minus x over 1 plus x all cubed. Perfect. Okay. The last part, sorry. Given that x and y vary so that ax plus by equal to c, show that the minimum value of x squared plus y squared equal to this. Okay, so they want us to get the minimum value of x squared plus y squared and then actually show that it is a minimum. So the new function that they want us to get the minimum of, let's just call it f of x being equal to x squared plus y squared, just like so, right? They want us to get the minimum and show that it's minimal. So to get the minimum, first of all, we have to keep in mind that f prime of x will be 0 for a minimum. And then to show it, we have to keep in mind f prime of x is greater than 0. So we have to find the derivative twice. So the function itself is ax plus by equal to 0, right? So I'm just going to substitute, equal to c. I'm going to substitute the value of y into the function f of x. So let's make y the subject. Over here, we have y equals negative a over b x plus the c. Okay, perfect. So now we can substitute. It means f of x would be x squared plus y squared. So negative a over b x plus c all squared. Right? So then this, I'm not going to expand that yet, okay? I'm going to try to differentiate this implicitly with respect to x. So we're going to find the derivative of a function implicitly first before I continue, because I don't want it to get bulky before I realize. So in this case, to differentiate implicitly, since it's with respect to x, it means it's the power of x that will be decreasing. So this will be 2x plus 2y dy by dx. That is the derivative implicitly. And then let's just differentiate it twice implicitly so that we will just be substituting later. This would be just 2 plus, okay, here we have two values which have been multiplied, and then we need to use the product rule. So u and v, yet again we do u dv. So u d of v is going to be d squared y over dx squared plus v du. So v is dy by dx. D of u with respect to y is 2y, okay, sorry, it's 2 dy by dx times v. So v du. This is v, this is du. Perfect. Simplifying this all together, 2 plus 2y d squared y by dx squared plus 2 dy by dx, all of this squared. So this is what we want to show that is greater than 0. F prime of x has to be greater than 0. So when we substitute all its values in here, that value should be greater than a 0. And then we should even show that the minimum value yet would be, I think it was a squared over b squared, let's see, c squared. Okay, we have to show that the minimum value will be c squared over a squared plus b squared. F prime of x, which has to be 0, would be 2x plus 2y dy by dx equal to 0. So we're doing this so that we can get the x value at which it is the minimum, right? Okay, so what is dy by dx? The derivative of y with respect to x. That's what we don't know. In the function given to us, this is a straight line, right? So dy by dx is the same as its gradient. So in that case, the gradient would be a over negative a over b. That's the gradient, which is the same as the derivative. So dy by dx is negative a over b. So if I substitute the value of dy by dx, we would have 2x plus 2y bracket negative a over b equal to 0. Okay, 2 is common. I can divide all through by 2 to cancel it out from the equation, right? So x plus y negative a over b equal to 0. Perfect. Okay, I'm going to substitute y as well. So y here, again, okay, here it was, is negative a over b. Oh, we had to divide all through by b. This is supposed to be c over b. Sorry about that. So x plus y would be negative ax plus c all divided by b. Okay, there we go. Times negative a over b. Expand our brackets again. X plus negative, let us see. Okay, negative a has to multiply negative ax plus c over, then the b squares multiply, get a common denominator, b squared x minus or plus negative a times negative ax is positive a squared x. That looks like a 9, so let me fix that up. Okay, minus ac over b squared. All of this equal to 0. Yet again, b squared cancels out. Okay, so I added a page. B squared x plus a squared x minus ac over b squared equal to 0. Okay, now let's move on. We have to find the value of x, so I'm just going to go ahead and factorize the x. So x parentheses a squared plus b squared minus ac over b squared, but I don't think I even need to put the b squared again, because when you cross multiply, it's going to cancel out, so equal to 0. So x can be equal to, I'm just going to add ac to both sides, ac over a squared plus b squared. And you're probably thinking that is what we needed, the minimum, which is not. So let's keep going. This is just the x value. We also need the y value. Okay, now the y value at the minimum point can be gotten by substituting x back into the function. So we're trying to get the minimum value of the function x squared plus y squared, right? Since we have to substitute the value of x back into the original equation, and yet again we still have y, we need to replace this y because we actually made this a function of x, right? So let's replace the y. We had ax plus by equal to c, and then y was negative ax plus c over b. Replacing this, f of x is equal to x squared plus value of y, which is negative x plus c over b all squared, which is just the same as multiplying it by itself. So ax plus c over b. Okay, we're done with this. Let's erase that. So yet again, we expand these brackets. X squared plus negative ax times negative ax is positive a squared x squared minus a cx plus, okay, minus a cx again plus c squared over b, over b squared. Then find the common denominator. This would be x squared b squared plus a squared x squared minus 2acx plus c squared all over b squared. All right then. I can factor out x squared from the first two terms. So x squared into a squared plus b squared minus 2acx plus c squared over b squared. Okay, now we're just going to slowly replace the x that we had so that we can get the minimum value. Okay, working just with the numerator, we had x being equal to, so here, ac over a squared plus b squared, all squared, that's x. Then a squared plus b squared plus minus 2ac x plus c squared. I'm going to substitute this x a bit later due to space, constraint of space. This would be a squared c squared over a squared plus b squared, all that squared, times a squared plus b squared plus c squared. And then one of these cancels out, thank goodness, to give us a squared c squared over a squared plus b squared minus, okay, I can substitute x now. We have 2ac, x was ac over a squared plus b squared plus c squared. That looks cumbersome, very, very cumbersome. This will be equal to a squared plus c squared over a squared plus b squared minus 2a squared c squared. Well, this is not a plus, okay? Maybe I'm just a little tired. Over a squared plus b squared plus c squared. So here we have a squared c squared minus 2a squared c squared, and they have common denominator. So 1 minus 2 is going to be negative 1. So this would be negative a squared c squared over a squared plus b squared. I can just go ahead and find a common denominator with this one. So plus c squared times ac squared, sorry, a squared plus b squared. There you go. Expanding the brackets yet again. A squared plus, sorry, a squared c squared plus, according to alphabetical order, a squared c squared plus b squared c squared all over a squared plus b squared. And then this is a negative. This would cancel out. And we can finally have b squared c squared over a squared plus b squared as our y value. But then let's remember that we were dealing with just the numerator, so we had to go ahead and divide this by the denominator. So if I divide this, dividing by b squared, you can use the keep, flip and change method, which is KFC, right? You keep, hold on, you keep this one constant, b squared c squared over a squared plus b squared. Keep this, flip over b squared, change the sign, cancel out, and we would have our proof. A squared plus e squared right over here. Your ED. That's the proof. Quantum errata demonstratum. Now this was actually a mouthful. Look at that. So I know I made a couple of mistakes, but we got the final answer. That is the proof in the question. Okay. Next question, number 15. Evaluate the integral of, we have a being x cos 2x dx, b being that, and c being that. Okay, so let's start with a, shall we? We want the integral from 0 to pi over 4 of x cos 2x dx. We're going to use integration by part, okay, where the integral of u dv should be equal to uv minus the integral of v du. So we're working in reverse. Let u, which should be the one that should be easy to differentiate, u should be x, and then v should be cos 2x, so that you can easily integrate it. According to the formula, we need u and v. Oh, this should be dv. If dv is cos x, for you to get v, you have to integrate both sides, just like this, so that v will be the integral of cos of 2x. Now, how do we integrate cos of 2x? Well, the integral of cos x in the first place is sine, so we should have sine of 2x, then we divide by this derivative of 2x, which is 2, so v is equal to sine 2x over 2. We also need du, which is just easy, that's 1. So according to integration by part, we have uv, so u is x, v is sine 2x over 2 minus integral of v du, so sine 2x over 2 times d of u, but d of u is just a1. d of u is 1 dx. Keep in mind. Okay, so we need to integrate sine 2 of x. Now the integral of sine is instead negative cos, so if I integrate just this value, I should have negative cos of 2x over 2 times the 2, which is already at the bottom, so times 1 over 2, right? Which practically gives me 4. So at the bottom, I should have a 4. And then here, I'll have x over 2 sine 2x. Okay, so then the integral of u dv is equal to this value. Keep in mind we are integrating from interval 0 to pi over 4, so I substitute each of them into the equation. Wherever we see x, we put pi over 4, so pi over 4 sine of 2x to pi over 4 over 2 plus cos of pi over cos 2 pi over 4 over 4, that's the first value, minus the second value. So wherever we put 0 wherever we see x, well, 0 sine 2 0, okay, this will obviously cancel out 2 a 0 minus, okay, there should be a minus here, minus cos 2 0, 2 times 0 over 4 to get our answer. We would have pi over 4 sine 2 times pi over 4 is pi over 2. So sine 90. So sine 90, which is 1. So the first term would be pi over 4 minus cos 90 as well, which is 0. So we'll rearrange this, minus second, which would be 0 minus cos of 0, which is definitely 1. There we go. So 1. This was all divided by 2. Okay, and then this was divided by 4. How could I forget the denominators? Alright then. This would be pi over 8 minus minus, which gives a plus 1 over 4. Bring them to common denominator if you want to. So it will be pi plus 2 over 8. Okay then, that's the final answer. So we want to find integral of x plus 7 over x plus 3, x minus 1, double check. Okay. There we go. Dx from 2 to 9. The first thing we want to do here is separate these, because the denominator is a quadratic, right? If we expand, it will be a quadratic. So we need to use partial fractions to simplify this first before we can even go ahead to integrate. So when we have two different roots, these are roots of a quadratic, the partial fraction a over x plus 3 plus b over x minus 1. So they're not repeated roots, right? So it has to be separate. Now this has to be equal to x plus 7 over x plus 3 x minus 1. Then here cross multiply so that we get a parentheses x minus 1 plus b parentheses x plus 3. I'll work just with the numerators so that this should be equivalent to x plus 7. Now when x equals 1, what happens? The a here cancels out, so we have a, we would have a into 0, 1 minus 1 is 0, plus b into 4 plus 1 plus, oopsies, equivalent to 1 plus 7, okay? And then for b equal to 8, so b equal to 2. When x again equal to negative 3, so that I can eliminate the b, right? This would imply a into negative 3 minus 1 plus b into 0 equal to negative 3 plus 7. This would be negative 4a equal positive 4, so a equals minus 1. So now we can separate our function into a set of partial functions, right? We want to integrate a, which is negative 1 over x plus 3, and we also want to integrate b, which was 2 over x minus 1. Okay, so we can have separate integrals. That works fine with respect to x. If we integrate this first one, we can let u be equal to x plus 3. So that will be integral of 1 over u dx. This would imply du by dx equal to x. Oopsies, equal to 1 if you differentiate that, so that this one goes over here and du becomes 1 dx. We now have to integrate 1 over u instead with respect to x, right? I'm going to change this and put du, because the function or the variable with which you're integrating has to be the same as its function. Both of them have to be du. Now the integral of 1 over u or 1 over x is the same as natural log, right? Natural log of that function. So in this case, our final integral for this is a -1, by the way. For -1 over x plus 3 should be equal to negative natural log of x plus 3. For the second part, very similar now that I already explained the first part. So I'm going to take this 2 out so that it becomes 2 integral of 1 over x minus 1 dx, right? Similar like I said. So this would be 2 natural log x minus 1. So the integral from 2 to 9 of x plus 7 over x plus 3 times x minus 1 should be equal to this one and this one. Negative natural log of x plus 3 plus 2x minus 1. Okay, now we're going to substitute the interval from 2 to 9. So we start with the bigger one, with 9, right? So negative natural log of 9 plus 3 plus 2 natural log of 9 minus 1, pardon, minus, we replace the 2 now, so negative ln 2 plus 3 plus 2 ln 2 minus 1. This would be negative ln 12 plus 2 ln 8 minus negative ln. So if I'm expanding this, I'm just going to put the resulted sign, right? So minus minus make a positive, so 2. We have ln 5 minus 2 ln 1. Okay, there we go. So ln 12 to the power minus 1 should multiply 8 to the power 2, right? And then on this side, I should have ln of 5 divided by 1 to be natural log 64. 12 is the same as 1 over 12, so divided by 12, and then again plus, so we have to times it by 5. Simplifying this, we should get natural log of 16 over 3 times 5 over 1, which is natural log of 80 over 3. There we go, we're done. The last question, last section, was to integrate x plus 1 over x plus 2 with intervals 3 and 2 over x plus 2 dx. We see that the numerator and the denominator have the same degree. So what do? We have to do long division, algebraic division. We have to do x plus 1 divided by x plus 2 so that we can get into its partial fractions. X divided by x is 1. X times 1 is x minus plus 2 here. So x minus x 0, 1 minus 1 is minus 1. So this can be rewritten as 1 and -1 over x plus 2. In this case, we can rewrite our partial fractions. This is 1 whole plus -1 over x plus 2. Rewrite this as 2 to 3 integral of 1 plus as well the integral of -1 over x plus 2 dx. Integral of 1 is just x, so this one is actually pretty simple. And then integral of -1 over this would be -ln x plus 2 as explained in the previous question. So then it goes from 2 to 3. We replace the boundaries. So we start with 3 plus n of 3 plus 2 minus 2 minus ln of 2 plus 2, 3 minus ln of 5. Well, I can just expand the brackets at once. Minus 2 plus ln of 4. Bring the natural logs together. So this would be 1. 3 minus 2 is 1. Plus ln of 4 minus ln of 5. When you're subtracting natural logs, you should divide them. So 1 plus natural log of 4 over 5. There you go. And finally, we can move on to the last question. Find y in terms of x, given that 1 plus x dy by dx equals to that, and that y equal to 1 when x equals to 0. The curve passes through 2, 2 and has at xy given by the differential equation that. Find the equation of the curve. Show that the curve also passes through this point and sketch the curve. Shall we? We want to have 1 plus x dy by dx equals 1 minus x y, and when x is 0, y is 1. So they want us to find the original function. Yet again, we need to differentiate, but this time around we have to be careful as to how we rearrange it. So we can see that this is already dy by dx, and if we integrate with respect to x, we should have y in x, right? So I'm just going to rearrange the equation with the y on one side and the x on one side. So let's start by dividing both sides by 1 plus x to get rid of it over here, so that this would be dy by dx equals 1 minus x over 1 plus x. Y. I have to carry this y over to where dy is, so I'm going to divide both sides by y, and then this will be 1 over y dy by dx equal 1 minus x over 1 plus x. Since we have all the x's here, let's take this one to the right hand side. So it goes up over there, and we have 1 over y dy by dy equals 1 minus x over 1 plus x dx. So now we are going to integrate each of these sides. The integral of y is going to be natural log of y. Well, they haven't given us any interval, so it's an indefinite integral. So this would be plus c, right? And then on the right hand side, we have the integral of 1 plus x. 1 plus x can be rewritten as a term or a function with these partial fractions, right? So let's quickly get the partial fractions of 1 minus x over 1 plus x, like in the previous question. This is the same as negative x plus 1 over 1 plus x. Okay, let's put the integral here so that we don't forget that we have not differentiated it yet, integrated it yet. Okay, using long division, this would be negative x plus 1 divided by x plus 1. So x divided by negative x is negative 1. Then we have negative x minus 1, and then we subtract to get a 0. Then we have 1 minus minus 1, which is positive 2. So this is the same as having the integral of 1 whole plus the integral of 2 over x plus 1, which is equal to x, negative x, pardon me, and then integrating this one, you should have 2 natural log of x plus 1. If I continue from here, this would be natural log of y equals, well, I can only put the c on one side, so I'm just going to choose the x side since it is dependent on x. So I'm just going to have its derivative, its integral here, plus its constant of integration. Now, they told us that when y is 1, x is 0. So in this case, I'm going to replace x with 0 and y with 1. So natural log, okay, there's not enough space. So natural log of 1 should be equal to negative 0 plus 2 natural log of 0 plus 1 plus c. Natural log of 1 is always 0, 0 plus 2 natural log of 1 plus c. This would be a 0 as well, 0, 0, and then plus c, so c is actually 0. Okay, c is 0. That boils down to a natural log of y being equal to negative x plus ln of x plus 1 squared. I decided to bring the 2 to the top. I'm just going to resize this. A curve passes through 2, 2, given by the differential equation y e to the power y dy by dx. Find the equation of the curve. So we have to find the original equation of the curve, just like this one, right? So we have second part, y e to the power y dy by dx equal to e to the power 2x. So we have to integrate again, rearrange these according to variables. So y will be on this side, and then e to the power 2x dx will be on that side. Integrate them separately. Well, this one looks easier to integrate, so I'm going to start off with that one. So integral of e to the power 2x, we're going to let u be 2x, so that the derivative of u would be 2. And then this would be the integral of e to the power u dx. But then dx, this was du by dx. So dx can be replaced with 1 over 2 du, so that we integrate u with respect to u. The integral of e to the u is still going to be e to the u. So e to the u over 2 plus a constant. That's it. So now for For integral of y to the power e y dy, we use integration by part again, where integral of u dv should be equal to uv minus integral of v du. So I'm gonna let u be, in this case, the y, dv, pardon me, by e to be e to the power y. Okay. Lastly, if I want to differentiate this, du would be equal to 1, and then dv, which is e to the power y. If I integrate it on both sides, I will get v equal to e to the power y. It's just going to stay the same. So then integral of y e to the power y dy should be y e to the power y minus integral of v, which is e to the power y, du. Du was 1, so times 1. Okay, this should be y e to the power y minus integral of e to the power y is still the same as e to the power y. So this would be equal to y e to the power y minus e to the power y equals e, the right hand side, which was e to the power 2x over 2 plus c. And then they told us it passes through the point 2, 2. So when x is 2, y is 2, right? We can find constant c. So at 2, 2, we should have 2e squared minus e squared equal to e squared plus c, and then 2e squared minus e squared is just going to be e squared, and then e to the power 4 plus c. So then in this case, this is over 2, e to the power 4 over 2. So then we should get e squared equal to e to the power 4 over 2 plus c, and this implies c is e squared minus e 4 over 2. Okay, it means that our function would be, let's get it from here, it would be y e to the power y. Okay, I can factor out e to the power y, y minus 1 equals e squared x over 2 plus the c, e squared minus e to the power 4 over 2. We simplify it, we should get our equation e to the power y, y minus 1 equals e squared x minus e to the power 4 over 2 plus e squared. Or we just put this on the same denominator, 2e squared. And there we have it. The next part says that we should prove or show that the curve also passes through this point, and we sketch it. So point 1 root 2, so through point 1 root 2, it means that when x is 1, y should be square root of 2. So we simplify and we substitute x in there. So the left hand side must be equal to the right hand side. So 2e to the power root 2 minus 1 equal to e to the power 2 times 1 to the power 4 plus 2e squared over 2. Okay, use your calculators, and if you plug this in, you would see that the left hand side would give you e squared times square root of 2 minus 1, which is 4.11. And then the right hand side, which is the same as e squared plus 2e squared, is 3e squared minus e squared e to the power 4 over 2. Okay, the right hand side would be 3 the left hand side is not equal to the right hand side, so it means that the question probably had a mistake, because this is the equation that I got even after working out this question a couple of times before bringing it on to YouTube for you guys to see. I worked it out and I had this equation twice at the end of the day, so that's probably a mistake. But then if you want to sketch this out, you can use decimals. I'm just going to put in the formula and you work it out just like so. That brings us to the end of this walkthrough, and if you found it helpful one way or the other, make sure to give me thumbs up. See you in the next